So in this session, we will discuss the first 6 problems of Codeforces Round 970. The very first problem of the contest is that there is someone having a math test and he is being given a number of ones and b number of twos, and yeah, it it has been given in an array, and in an array, what is the name? Sakurako. Sakurako must place either a positive sign or a negative sign in front of each element so that the sum of all the elements in the array becomes equal to 0. And we have to tell if Sakurako is would be able to assign positive or negative signs to all the elements and make the sum equal to 0 or not. So is the problem clear? Like, did you guys understand what we have to do in the problem? Basically,
Please
we
explain
would be
last statement. What is the last statement?
yeah, the last statement is that Sakurako is not sure if it is possible to solve the problem, basically make sure that the sum of elements becomes 0. So we have to determine if there is a way to assign these signs, or is it not possible. So it's like you will be given some array, not really an array, you would be given two integers, a and b, which denotes the number of ones in the array and the number of twos in the array. And let's say if a is equal to 3, or actually a is equal to 4 and b is equal to 3 maybe, then it means that there will be an array having 4 ones and 3 twos, and you will have to assign positive or negative sign to each and every element in the array. And what you want to do is assign the signs in such a way that at the end of the day the sum of all the elements should become equal to 0. So is the problem clear now?
Is the number of ones and twos order fixed or they can be randomly placed?
It won't really matter, and the problem didn't specify it, so we should assume that they can be random, but it won't really matter because let's say if instead of having the array like this, if the array was something like 2 2 1 1 1 2 1, something like this, then again you can just assign the same signs but at different places. So the answer should remain the same. If it is if the answer for this is yes, then it should be yes for this as well, and the same way. Okay, so let's just write down the trivial things. Just assume if the number of ones is is odd. Let's say if a is odd, then would it be possible to uh, assign the signs in such a way that the sum becomes equal to 0? Or maybe before that, let's analyze one thing. How will you assign the signs? You would like to assign the positive sign uh, to some elements such that the sum of those elements should be equal to the total sum of array by 2. And similarly assign negative sign to the other elements so that their sum would also be equal to total sum by 2. Right. Now if the number of ones is odd, then the total sum would be odd as well, right? If the number of a's is odd. So in that case, it would like uh, if you are having total sum as odd, then obviously you cannot have a fraction, maybe like if total sum is equal to 7, then 7 by 2 is 3.5. And since you're having only ones and twos in the array, you can't really have this as the total sum of the elements which you choose to have positive sign. So obviously in this case, the answer
क्या
should be no.
क्या डेटा रैंडलिंग
I think
डेटा रैंडलिंग
you forgot your
ये
mic.
नहीं सुना मैंने
Yeah. Okay. Nice. Okay. I hope that this is clear. Now, uh, this was the trivial observation which you should definitely have in mind just after reading the problem. And there was one more case. Like let's say if um, B is something like 3 and A is something like 4, the case which we just discussed right before. In that case, how will you make sure that the total sum is 0? You see, you're having three twos, so their sum would be equal to 6, either positive or negative, but the absolute sum of absolute values would be 6, and the sum of absolute values of the ones would be 4. So you would like to have the sum of the elements which uh, you assign the positive sign, like their sum should be 5, and for the values which you assign as negative signs, their sum should also be 5, right? So in this case, it would be possible. You can have something like two twos and 1 1. And for the negative elements, you can have one of the remaining twos and the remaining three ones. Okay, I think it would be looking like that. Basically, 1 2 and three ones, and two twos and 1 1. You can have something like this, right? But what if you don't have ones? What if the number of ones is 0? In that case, if let's say the number of twos, if let's say B is odd, maybe if you're having three number of twos, you won't be able to have the total sum by 2, because in this case the sum of absolute values would be 6, so you would like to have 3 and 3 as the sums of the positive and negative elements. But how will you get the sum of 3 if you're not having ones? So I hope you got the idea that like you would like to have some value for the positive elements and exact same sum for the negative elements so that they cancel out each other. In case if this value is negative and you don't have any ones, in that case you won't be able to uh, make the total sum of the array to be 0. And in all the other cases, if you are having even two number of ones, then you can just assign 1 and 1 1 here and make sure that you would always be able to divide the array into two parts like this. Okay, so uh, the ones in the meet, can you guys please give me some idea of whether the problem is clear or not? Okay, clear.
So just a doubt. I mean, like A is the number of ones. Am I correct?
Yes, yes.
Okay, so then we can simply say that we can say that we can say that if on the input if B is half of A, then it's true. We can say that, right?
Uh, yeah, in that case, the answer will be true, but it would be true in many more cases. Like if B is 0 and A is 2, even in that case, the answer is true, even though B is not half of A.
Oh, okay, got it.
Okay,
Okay,
great. Yeah.
but okay, the got it. But this odd even part that I didn't fully get it. Can you please come back?
Yeah, I can just have a recap of the explanation. So we had A number of ones and B number of twos.
Mhm.
And in the array, we had to assign some elements the positive sign and some elements the negative sign. So our motive was, let's say if uh, total sum, let's say if this variable is telling me about the uh, sum of the absolute values of all the elements, or basically total sum is nothing but A plus 2 into B. So I would like to have the sum of the positive elements as total sum by 2 and the negative elements sum as total sum by 2, so that the overall sum of the array will become 0, right?
Yeah. Okay. Okay.
Yeah. Yeah. So the first thing which I pointed out was if A is odd, in that case the total sum would be odd. So total sum by 2, this thing will come out to be uh, not an integer. Basically, it can be something like 7.2, which is 3.5, basically a decimal. And uh, we can't have a decimal sum of the positive elements because all the elements here are integers. So the first condition was if A is odd, then the answer is definitely false.
Okay.
Now we are assuming that A would either like A would be positive. Sorry, A would be even.
Okay.
Now we are assuming this. Now the second case, which I think some people could have missed, at least some beginners could have missed, uh, is that even if A is even, there is a chance that you might not be able to divide the array into two parts. It can be like if let's say A is 0 and B is something like 3 or
Odd.
5.
Yes.
In that case, what would be the value of total sum? Total sum would be equal to 6 here. So you would like to have 3 as the sum of the positive elements and 3 as the sum of the negative elements. But would you be able to have 3 as the sum where you are having only 2, 2, 2 as the elements in the array? Would you be able to have
No,
like
sir.
make it? No. Even two number of ones, like A was anything greater than 2, any even value greater than 2. In that case, now would it be a problem? Like whatever be the total sum of the array, maybe it can be 10, 12, 14, whatever. Let's say if it is 14 at some place, then you would like to have 7, 7 as the sums of positive and negative values. Would you be able to make these values now? The thing is,
Yeah.
you can like whatever number of A's you had, assuming that it was greater than equal to 2, you can just assign one of the ones as positive and one of the ones as negative. So you will have A minus 2 number of ones left, and you will have uh, some B left, right? Now it would be like pretty simple because these values would be even. Like let's say if B is equal to 3, actually, yeah, B can be 3 and A is 6. So you can do something like this. Assign one B, like one of the twos to be negative, and assign two of the ones to be positive. And keep on repeating this until either the number of ones are dead or the number of twos are dead, and then uh, whatever the remaining ones or twos you have, you can just divide them in two halves. Like I think now it can be clear, but if it is not clear even at this point, like this part, then I think you can just do a little bit of dry run. It would be more clear in that case. For now, just assume that, yeah, it would always be possible. Maybe just accept it. Um, and I think your doubt was not here, but it was something uh, here. Uh, like, is your doubt clear, or did you want to ask something else? Okay, great. So, shall we move on? Okay, great. So, the first we got, this is the first case where we would fail. The second case where we are failing is if A is 0 and B is odd. In all the other cases, like if A is greater than equal to 2, it does not really matter whether B is even or odd because you can just use these ones for making sure that the desired values achieved, basically total sum by 2. It should always be achievable. Okay, you don't even need to think in this way. Just think in this way. Let's say total sum by 2 is the target sum which you want for the positive elements. So if this value is odd, in that case, uh, make one of the ones to be positive. So the remaining target value would be now even. And after that, you can just start putting up the twos to be positive values until total sum by two. This value becomes equal to zero until you achieve this target. And let's say if the number of twos are exhausted in the process, then you can use the remaining ones. I think it's good enough now. So let's move on to the code.
So if
Code
the
is pretty simple.
odd, we have to like take two ones and make it even, right? The two
Yeah, yeah,
divided by two is odd. Yeah.
yeah. If this thing is odd, then you would require a one. Okay, great. So the code is pretty simple. You can just okay. You can ignore these lines and basically just ignore everything and focus only on the content inside the function with name solve. Uh, this solve function would be called for each and every test case. Now it's the best thing for now is just focus on this part and ignore everything else if you don't know about the lambda functions or about the debug macros. Okay, so first of all, we can take the inputs. Now the next thing is, uh, yeah, basically you can just write these conditions. It should be sufficient. During the contest, what I did was uh, make b like I did b mod equal to 2. So if b is even, in that case, if b is even, then b will become 0. And if b is odd, in that case, there will be a remainder 1. So b will be 0 or 1. And here I'm checking if b is 0. So you could have directly checked if b is even or not. And yeah, we're just having the sort of same uh, conditions in the different order. First of all, I'm checking if A is odd or not. If A is not odd, in that case, I'm checking if either the number of ones is greater than or equal to 2 or the number of twos should be even. Then in that case, I'm printing yes, otherwise I will print 1. So is this clear? And shall we move on to the second problem? Okay, great. I think we spent a lot of time on a problem, so let's hurry on a bit. Or like, in case if you want, we can go with the speed as well. There is no problem. The second problem says that a matrix, yeah, a matrix is considered to be beautiful if all the ones at the border or the edges are ones and all the other cells are having zeros. Okay, I think I said it wrong earlier. Basically, if you have a matrix and in the matrix, all the elements which are at the border, basically these, if these elements are equal to 1 and all the other elements which are in the middle are equal to 0, then this matrix would be called beautiful. So they have given some examples. This is a beautiful matrix. This is a beautiful matrix. Similarly, this one and this one as well. It is not having any zeros because it does not have any elements which are not at the border. So the problem says that they would have given you a string. The string would be in such a way like uh, for a for a matrix like this, the string would be just one second. Yeah, the string would be 1, 1, 1, 1, these ones. Then you have 1, 0, 0, 1. So 1, 0, 0, 1. Then you have 1, 1, 1, 1. So you will have 1, 1, 1, 1 here. So for representing this matrix, you would be given this string. And obviously, this string does not represent only this matrix, it can represent even more matrices. As an example, someone might say that I will consider these as zeros. So from string to matrix, someone might create a matrix like uh, this one. So basically, the point is you would be given the string which is created from a beautiful matrix. Now you have to tell whether it is possible or not that the matrix from which this string has been created um, is a beautiful square matrix. Beautiful square matrix. Okay, great. So we will have to tell if the given string can be formed from a beautiful squared matrix or not. And the conditions for a matrix to be beautiful square matrix is the number of rows should be equal to the number of columns and the matrix should be beautiful. So guys, does the problem make sense? Let me take one example. I think it will make more sense then. Let's look at the third test case. You have been given a string like this one. Now for a string like um, 1 1 1 1 0 1 1 1 1, you can form three type of matrices. One of the matrices which you can create is this 1 1 1 1 0 and these ones. Basically, this is a matrix having one row and um, 9 columns. Unfortunately, this is neither beautiful nor a squared matrix. The other way in which you could create a matrix is like this 1 1 1 1 1 0 1 1 1. This is both beautiful and squared. So we found a matrix which can be represented in this way, a string like this, and this is a beautiful matrix. So here our answer should be yes. So we will just have to identify that across all the matrices which can be created or which could have represented the string, uh, is there any matrix which is both beautiful and squared? Does it make sense? Okay, the chat has gone dead. Okay, somebody replied. Great. So the logic is simple. Let's say if you have been given a string of length n and you want to check if it is possible that there is a beautiful square matrix which could represent a string of length n, then there should be square root n number of rows and square root n number of columns in the squared matrix, right? Because in that case you will have n number of cells if this is the number of rows and this is the number of columns. Then there will be a number of cells and uh, this makes it easy for us that the first thing which we can check is if n is like whether n is a perfect square or not. Whether n is a perfect square. right? Secondly, if n is a perfect square, then we got the number of rows, we got the number of columns. So if we know the number of rows and columns, can't we easily create a matrix? And once we create a matrix from this string, can't we easily check if this is a beautiful matrix or not? Because for that, we just need to look at the, like for every cell, we can just check if it is either a part of the first row or the last row or the first column or the last column. If it is a part of any of these, in that case, the value should be 1, otherwise the value should be 0. And if this thing follows for each and every cell in the matrix, then it is a beautiful matrix, else it is not. So guys, does it make sense? I can see only one active person in the chat. Okay, great. So let me show you the code. The code is pretty simple. Again, just look inside the content for the solve function, and you can look at this part as well if you want, but it's not really necessary because there is a built-in function for finding square root. So you can use that instead of writing your own function. In my case, I had a snippet, so I used this one. Uh, First of all, I'm taking the inputs, then I'm calculating the square root of the number. Now, if this is a perfect square, like what will happen is, if n is something like 22, then the function which I have called square root, it will return me like square root of 22 should be something like 4.6 or 4.7. Maybe let's say if it is something like 4.65 for now, uh, then my function will return me 4. So I'm just checking if the number I got multiplied with itself is actually equal to the original number or not. Because in case if it is a perfect square, if it was a perfect square, then I would have actually got the real square root number, and multiplying them would give me the actual number. So this is the way in which I did check if I'm having a perfect square or not, but there are other ways if you don't like this one. Some people generally say they will check if floor of square root n is equal to seal of square root n or not. Okay, somebody has written this in chat as well.
सर
Yeah. Yes.
जो भी आपने लिखा है फ्लोर ऑफ स्क्वायर रूट ऑफ एन इक्वल इक्वल सील ऑफ स्क्वायर रूट ऑफ एन, मैंने ये
Yep.
किसी पहले प्रीवियस कॉन्टेस्ट में कभी यूज करा था, तो सर मेरे ये टेस्ट केस फेल हो गए थे। तो फिर मुझे पता चला था कि मतलब इसे लॉन्ग डबल में लिखना पड़ता है कि प्रिसिशन लॉस हो जाता है सर, क्योंकि
I'm not
ऐसा है
sure
क्या?
if yeah, like there is a precision loss in double, but I'm not sure if it is in, like, I
बिकॉज
think it should be
वी
there
हैव
in long double also. Like I believe that long double should also fail at some place. So this is why I don't recommend this one.
सर, सो माय अप्रोच इज रॉन्ग।
No,
आई
no.
हैव सेंट यू इन दी
Uh,
डीएम।
yeah, I saw your DM. Your approach is not incorrect, but the thing is, since the square root of n will return you either a double or actually a long double, I see in
So
your
it
code.
will so basically it will depend on that what I have passed in the square root function. If I will pass a long double, then the long double definition will be called of square root, right?
No, no. The square root function will return you a double. If you want a long double, then there is a function square root L.
Okay.
This L is representing the like long.
So
Long or long double?
Uh, like if you call the function square root of n, I think it will return you a double, and if you call square root L, then it should return you long double.
so
I think it's easier to do R equals the one that I pasted.
yes, sir. But I have one
Yeah,
doubt.
yeah,
That जो सी मैथ क्लास है उसमें
yes.
स्क्वायर रूट फंक्शन की डेफिनेशन लिखी है और वहां पर स्क्वायर रूट फंक्शन ओवरलोड हो रखा होगा, तो अगर मैं इंटीजर n पास करूंगा तो वो इंटीजर वाले फंक्शन से उसे बाइंड कर देगा, अगर मैं डबल पास करूंगा तो डबल वाले फंक्शन से बाइंड कर देगा, एंड इट विल रिटर्न अकॉर्डिंगली, या राइट?
I have to look at the definition for that. Like this is something which was making sense that if they're having a function square root L, then maybe square root n always return double. But yeah, it might be possible. What you are saying might be correct. Yeah, anyway,
So is this a case that my system test case will fail?
yeah, देखो, it's on your luck. You know that
Okay.
even if you're using long double, it is still gonna have precision errors.
Yes, sir.
There will still be precision errors. So it's on your luck whether you are getting the correct output or not.
Okay, thank you.
Yeah. Yeah. From my side, I would always recommend you to use this method in
Yes, sir.
which you are basically first of all calculating the square root. And in my case, I do prefer to use my own function, which you can see here. Like I always use my snippet instead of using the inbuilt function because like inbuilt function is internally using long or sorry double or long double whatever. So there are still, I think, some chances of getting wrong answer. That's why I think it's always better to just use your own snippet and calculate the square root and then check square root of into square root equal to n or not.
सर इट मींस मतलब जब भी स्क्वायर रूट फंक्शन यूज करना हो तो खुद का मतलब डिफाइन कर लो, इनबिल्ट यूज नहीं करें.
Uh, yeah, like this is something which I prefer, but I
Yes,
have
sir.
seen even some grandmasters using the inbuilt function. So uh,
Yes.
I'm not sure of how much does it fail or not. I just don't like
Yes.
to take any risk here because
Yes.
keeping a snippet of square root is not a problem.
Yes.
Yeah. So um, I think you would be quite unlucky that you got this problem at some place because the chances are very low unless somebody has intentionally created a test case to blow it up.
Yes.
Okay, so is everything else clear? And I think we had discussed the complete approach. So guys, is the complete approach clear? Or does anybody have any doubt at any place? If you have, then please mention.
Can you go to your code once? Wanted to see your edge case, edge variable that you had.
Yeah, we will discuss the code as well. Yeah, until you are seeing the code. Anybody else having any problem in the approach? If not, then yeah, let's discuss the approach. So I'm having this square root function as a snippet, which I've already written before the contest and I can copy paste. So that's why I'm using it, but feel free to use the inbuilt function as well. So what I'm doing here is, first of all, taking the inputs. Then I have been checking if n is a perfect square or not. After that, I have been, okay, I'm not using this grid, I think, at any place. You don't really need to create a matrix. Like, you can visualize that you're creating a matrix, but uh, would it really matter if you put up these values inside a vector of vector, or you just compare the position you have with the value you have? Like, it won't really matter now. So what I'm doing here is, on the basis of I and j, basically row number and column number, I'm checking if I should like if this cell should come at the edge or not, basically at one of these places or not. And after that, I'm checking if, okay, so the thing is, if the cell is coming at edge, then you would like to have uh, like the cell to be 1, Or in the other case, like if the edge is false, then you would like to have cell equal to 0, right? So either you can write it like this, it will just make your code a bit lengthy, but it would be a lot more readable. Or you can shorten it a bit by saying, like, by just using the fact that this is nothing but a and b plus um, a bar dot b bar, if you have ever heard about this in Boolean algebra or like whatever. Basically, we can just use the XOR here. We can use the XOR operator to say is edge or cell is 0. Basically, I have written this thing in short like this, but you can feel free to totally disregard this and write it in the longer form. It's totally up to you, in whichever way you feel more comfortable. So I think you can just write this in your own way, in whichever way you want to write the if condition. And this if condition is just checking that in case if, like by writing here one, I'm just checking if there is any cell violating the conditions we had for beautiful array, beautiful matrix. So if anybody is violating that, in that case, the matrix is not beautiful and I can straight away say no. Otherwise, if for none of the cells we fail, then you can print yes. So guys, does it make sense?
Can you explain your is edge condition? Like why and on, why not? Like why is on, why not and? Like it makes it like
This one.
look like a complex one. Yeah, we could expand it, but if we can get to write this one as well, like how did you do this? But
Okay, okay. Uh, do you know what XOR?
yeah, yeah.
Okay. So one thing is that you can just uh, do some hit and trial on your own. Like one thing, yeah, this is a very simple thing you can do. Generally, what I do is if I have something like uh, this condition, you already get the idea in your head that maybe I can replace these operators by just a XOR operator. So what I do is I just write the first condition, XOR the second condition, and then I try to think in what cases this would be true and in what
XOR is an
cases
odd
this would
one
be
detector,
false.
right?
Huh?
XOR is an odd one detector. That logic I got.
Yeah.
So like if A is true and B is true, we want the expression to be true. Uh,
Uh,
like or both of them false, so then also it is like zero only.
yeah.
So,
Uh,
since OR is an odd one detector, like if one is one and another one is zero, then it's a false condition and it will go to, I think. But the condition that you have written inside that square bracket, if you go to your code,
yeah.
this one I into SQ plus J.
Okay. Okay. You are asking about this. See, I think this is even mentioned in the problem that the element from the matrix in the ith row and jth column would correspond uh, to this uh, place in the string, and this is where we are having I and j in the one based indexing, but in the code we are having I and j in the zero based indexing. So instead of I minus one, we will have I, and this is talking about the uh, like you see. Um, yeah, let's say the string was 111 1111 0 1111, and you're talking about row 2 column 1. So the indices here are 0 1 2 3 4 5 6, Now, the first three elements would belong to row 1. After that, for row 2, these three would be the elements, and
Correct.
this one is the first element. So this would be the uh, row 2 and column 1, right?
So,
Yeah.
okay.
So according to the problem, the way if we are having these in one based indexing,
So,
yeah, and we are trying to find out the uh, row 2 column 1 guy, then it would be row minus 1, that is 1 into the number of columns, that is 3, plus 1, that is fourth guy, right?
plus 0, right? J starts
Yeah.
for yours case as 0.
Uh, no, this is something according to the problem, like where we are
Okay.
having one based
Okay.
indexing. So it
Okay.
would be fourth guy.
Okay.
Now
Okay.
in our case, it would be like row would be equal to 0.
Hmm.
Sorry, row would be equal to 1 and column would be equal to 0.
Correct.
So in our case, in the string, it would be like, uh, you know, this, if you are having row equal to 1, we are talking about the second row, right?
Mm-hmm.
So uh, instead of the place where we were having row minus 1, basically this row minus 1 into C is telling you that this many people have already been passed in the previous rows. And then you are saying that this is the jth column. Now in our case, uh, the jth column would be coming up at j minus 1 index, and we are
J.
having 0 based indexing, so instead of j minus 1 it would be j. Okay, like
J
I
minus
think
was correct, right?
what
J minus 1 is correct, right?
no, no, no.
Uh,
Yeah, I think this is like it would be easier to just dry run this instead
okay.
of
Okay. Yeah. 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 Yeah.
visualizing.
Got it. Yeah. Yeah.
Yeah, you can just dry run that whether I should put up a j or j minus 1 in.
Mm-hmm. Yes.
Yeah,
Thank you.
yeah. It was looking like hard to describe because it is a bit more basic than we should discuss.
Yeah. Yeah. Thanks.
Okay, anyways. Uh, Anybody having any doubt in the B problem, including the code? Okay, no. Okay, great. Let's move on to the C problem then. Longest code array. So, yeah, the problem says that an array is considered good if these two conditions are satisfied for that. So, for an array, the first condition is that it should be strictly increasing. What we mean by strictly increasing is that every element should be greater than the previous element. For every element, it should be greater than the previous element. This is the first condition. And the second condition is that the difference between, okay, let's say if we are having three elements here, A1, A2, A3, we already know that A1 should be less than A2 and A2 should be less than A3. Okay, somebody's having this mic on. Yeah, fine. Okay, so we already know that A1 would be less than A2 and A2 would be less than A3. There is one more condition, that is A2 minus A1 should also be less than A3 minus A2. Basically, the gap between these two should be greater than the gap between these two. If we denote the differences by D1 and D2, D2 should be greater. And we are being given two integers L and R. We have to tell the maximum size of any array we can have, which like we have to tell the maximum size of any array which is good. Like the first thing is it should be good, and all the elements of the array should be greater than equal to L and less than equal to R. Does it make sense? Like, is the problem clear? Guys, yes, no? Okay, great. So I think this one was very straightforward, that since you want to maximize the number of elements you can have in the range from L to R, you would like to have their differences, the differences between the consecutive elements, to be as small as possible, so that you can have more elements in the range from L to R, right? And the second thing is you would like to have the first element as L, like you would like to have the first element A0 being equal to L, because if you're having A0 greater than L, then you're already making the range even smaller for you for the elements you have to put in. So I believe that this is first condition, first observation you should have in your mind. And the other observation you should have in your mind is the difference between consecutive elements. Oh, sorry. Yeah, consecutive elements should be as small as possible. Would anyone like to guess what we can do for this?
Yes,
Uh,
sir.
it looks like a triangular series,
What is a triangular series?
where the common difference follows the arithmetic progression.
Uh,
It's like AP of AP,
okay,
sir.
yeah, got it.
Right. So what we can do is we want the range to be R minus L. Like say example that in the triangular series, uh, the first element is denoted by A1 and the last element is denoted by say AK plus 1. Like we can basically write a formula. It reduces to a simple quadratic expression. It's a O of 1 solution. I did.
Um, not really O of one, but yeah, it would be efficient. Maybe there
So
can be a big of O, like big of one solution, which I don't know about. Mm, Like
But
I looked at,
since the differences follow AP, it's
yeah,
I think
yeah,
easy
that
with
thing is,
sir,
the
uh,
it
maths.
will be like square root of R minus L, na?
uh, yeah,
Basically square root of N type solution.
uh, yeah. Either you can do it as square root of n or apply binary search.
Yes.
Like for the solution of square root of r minus l, for that solution there can be some TLE, because r minus l can be as long, like as large as big of 10 raised to the power 9 under rooted. So something like 3 into 10 raised to the power 4. And there are 10 raised to the power 4 test cases, I think. So ideally this should give TLE, but it did not give TLE. I saw a solution, a person who had actually submitted the solution. Uh, but in the other cases, everyone else I saw actually applied binary search. They had big of log and solution. So the main idea is you would love to have the first element being equal to L. This is something quite obvious. The second thing is you would like to have the difference between consecutive elements to be as small as possible. So what is the smallest element you can have? This the second element. It's obviously L plus 1, because you can't have L anymore since you want the second element to be strictly greater than the first. Now for the next element, you would love to have it as L plus 2, but the difference here is equal to 1, and you would have, like,
Plus
you
3, right?
need to have a greater difference. So you need at least L plus 3. Now, again, you would have to pick up an element with at least 3 as the difference. So it must
3
be at
plus
least L
6.
plus 6. Then 4, so L plus 10, and so on. So you would notice that if you're having zero-based indexing, this is the first, like, element at index 0, element 1, index 2, index 3, index 4, and so on. Then you can denote AI as L plus the sum of the first I natural numbers. Right. You can just look at this. How is this L plus 10? The element at index 4. Because we got plus 1 at index 1, another plus 2 at index 2, then plus 3 for index 3, then plus 4 for index 4, and eventually we ended up having L plus 10 at the index 4 in total. So we can formulate something like this. Now
Can
we, yeah,
can you repeat this once? Like, what did you do?
uh, like,
Yeah,
did you not understand this part, that
yeah,
how
this
are
one.
we formulating this?
Kind of. Can you just repeat it once? It's already fine. No.
Okay. So the thing is, we want the first element to be equal to L, and after that, we just realize that for the first element, for the element at index 1, L plus 1 is the smallest element which you can have. Then you need the next element to be at least 2 greater, so you got to L plus 1 plus 2, that is L plus 3. Then you require the next element to be at least 3 more than the second. So you got it to be L plus 1 plus 2 plus 3, like you added this plus 3 here. Then on the next turn, when you had been required to have at least plus 4, then the last element. So the current element is nothing but L plus 1 plus 2 plus 3 plus
Yeah,
4,
yeah. Got it. Yeah.
and so on. So this is equivalent to this for the ith element, or basically the element at index I. So now you just want to know about the largest I such that AI is less than equal to R, right? You just want to find out that element. Once you figure out that element, you would know that your answer is nothing but I plus 1. Does it make sense?
I plus 1. Oh,
Like, if on index I the element is less than equal to R, then from index 0 till I there are I plus 1 elements now.
okay.
And yeah, and you know that this is the largest I for which the element is less than equal to R, so it means that AI plus 1 is greater than R. Otherwise, I would have been 1 greater than its current value. Okay, so we can just apply binary search at this place. And by the way, Dominator used uh, a normal for loop. Basically, he just applied a linear search and it worked out. But this was something which looked a bit risky to me because of the number of iterations we can have. But in general, if you see, like, we are having 3 into 10 raised to the power 8 iterations, and we are not having any extra constant factor. So in general, this should run within 3 seconds, and in practice, it would run within 1 second. So this is something you could have taken risk
So
of.
like
And
R minus L is a large range, right?
yeah, R minus L is 10 raised to the power 9. And uh, the value of AI would increase
Uh,
quadratically,
yeah, square every time.
right? So there should be around 10 raised to the power 9, square root of 10 raised to the power 9 iterations, or actually a bit
10 to the
greater than
power
that. Actually,
approx
something like,
5.
not really.
Yeah,
10
I
raised to
think,
the power 5, but less than that a bit.
yeah, but in worst case, if we are
Uh,
not sure. Yeah.
yeah, we
But
are
it's
already considering the worst case. Even in the worst case, it is uh, not gonna go till 10 raised to the power 5. And like in general, it would be, uh, according to me, in the worst case, which I was considering, it was around 6 into 10 raised to the power 8, because
Raghav, like,
computation here is n square by 2, not really n square. So there will be double iterations of what we were earlier counting. And it can pass actually, because we are not having any extra constant factor, but it can fail as well. So I didn't take any risk. Okay, yeah, you can ask now.
yeah, the easier thing in this question, like via mathematical, is, say example, you have written AI here, right? Uh, so we can say AI minus A0 is less than equals R minus L, right?
Yep.
And then if we are starting from L, L plus this entire thing minus L is less than equals R minus L, right?
Okay, so basically you are saying 1
Yeah,
plus 2 plus I to be less than equal to
R minus L,
R minus L. Now you
right?
want to figure out the largest value of I.
Largest I. So I plus 1 by 2 is less than equals this one.
Yeah,
And
and this
that's
is
for the
nothing but
quadratic.
I into I plus 1 by 2, and this is R minus L, and uh, I square plus I is less than equal to 2 into R minus L, which is a constant, which is T. So we have got this square root. But yeah, still you would require log n, I think, even
Uh,
in this
why
case.
login?
Uh, like how will you solve it in big O of 1? If you want to find
We
out the
need to
square
find the
root,
value of I, right?
yeah, for finding out the value of I, like,
It's a
uh,
quadratic expression. So minus B plus minus root D upon 2A.
yeah, you will have a root there na, in the formula. And for finding the root, you would require a log n.
Okay, log n as in your square root
Yeah,
based.
yeah, square root function will take big of log n time anyways.
Okay, okay. Even in the pre-STL one also.
Uh, Actually, like, we don't know about its implementation, but some people say that it performs equivalent to big of 1. I don't know what is the actual time complexity, but it is comparable to big of 1. That's what some people say. Uh, I'm not sure. It might be rumors as well.
I actually did this thing only, that computing D,
Hmm.
and this was my solution, like what I pasted right now. Uh,
Okay.
so I was getting an offset of 1, so I did K plus 1, but I didn't get why.
Yeah, actually, in my case as well, I had done it in this way that, uh, like, I took the L on the other side and did R minus L, basically this difference, and wanted to find out this largest value.
And that plus 1
And
is because we are starting from L or Y. What was that?
uh, which one? Which
Uh,
plus one?
that
Okay,
that
the
that
offset plus
I was
one
having
because
an
of this
offset
guy.
of 1.
It was because of this guy.
Okay, 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 okay.
It's actually 0 plus 1 plus so on.
Yes, 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 yes. Got it, got it.
Yeah.
Yep.
Yeah, so let me show you my code. So in my code, uh, this is just a small function which I created for finding out the sum of first n natural numbers. I will pass on n to it and it will return me the sum of n natural numbers. Yeah, so coming up to the main code. First of all, I took the inputs. Then the next thing, which as we just discussed right now, that we can write this thing as AI as L plus this part, and then take this L on the right hand side. So we would be left with this thing. That was the main idea there. That I wrote R minus LSX and applied a binary search for finding out the biggest value of I, such that the sum of first I natural numbers should be less than equal to X. We can do it in this way either, like either in this way, or think in this way: what is the maximum size of the array I can have? Let's say if the size of the array is L, then what will be the sum of the elements? It would be the sum till uh, the first L minus 1 natural numbers, because we are having the first way as well. Like, think in any way you want. I think since we have discussed this approach till now from the beginning, you can code it up in this way: that search for the biggest value of I such that the sum of the first natural numbers is less than equal to R minus L. That is, I into I plus 1 is natural by 2 is less than equal to R minus L. And whatever value of I you get, the answer is gonna be I plus 1.
So, or we can simply say that search for the smallest I for which sum is greater than R minus L and I will be our answer, right?
Yeah, that one also works.
Yeah.
Okay, so that's it for this problem. So is everything clear, or is anybody having any doubt?
Sir,
Yeah.
in your code, you have also used the same approach of the equation, man.
In my case, the approach is
The code that you
same
have
till
uploaded.
this point. Like, uh, basically, the way of thinking is the exact same. Just the difference is on the variable for which I have applied the binary search. Instead of applying the binary search to find out the largest I applied binary search to find out the largest size of the array. So it was almost the same thing. Here I'm having this is the formula, and then I'm saying I plus 1 is the answer. In my case, I was having this as the condition, not
Okay,
element, size, and
what
size
I'm
is,
asking is that in this equation, we can't take equal to. We have to take both condition less than or equal to, right?
yeah, less than equal to.
This thing. Okay, and then while applying the quadratic formula, it will be minus b plus minus root d upon 2a, and whatever be the solution plus 1 to it.
Um, yeah, it should be like that only. Whatever the formula you have, just make sure that you remember one thing. If your answer is coming up as 3.7 mathematically, you have to give 3 as the answer. And it depends
Okay.
upon the way you implement, like the plus 1 minus 1 thing. I generally prefer to just do the dry run at the end whenever I approach any mathematical problem. That whatever approach I have in mind, after thinking about it, do a dry run to think about the plus 1 minus 1 thing.
Okay, thank.
Okay, great. So let's move on to the next problem then. Now, uh, we will have to go a bit faster. So we will not really go in a lot of details for the explanation. Instead, we will discuss more on the approach part on how to think for solving these problems. And like that's what we expect for the ones who are coming up at the D problem. So the problem here says that we would be given a permutation of n elements, and there is one definition that an integer j is considered to be reachable from integer I if it is possible to make I equal to j by assigning I whatever. Like, let's say if you are having a permutation 3 5 6 1 2 4, then all the elements like again, so the indices here are 1, 2, 3, 4, 5, 6. So for the element 3, like the value here is 3. Let's go to the index 3. The value at index 3 is equal to 6. So let's go to the index 6. Here the value is 4. So let's go to the index 4. From here, let's go to the index 1. Now, all the values, all the indices where you are able to reach would be called reachable from this index, considering that you are always going on to the index for which you are having the value at the current place. Like at the current place, if you are having a value I, then you are going to the index I. If you're traveling in this way, then all of these nodes would be considered to be reachable from this index, from this index, from this index, and from this index, because you can just go to any one of these, right? And this is true for all of these. They can go to each and like any one of these indices. And we have been told that Sakurako defines the function f of I as the number of black integers that are reachable. So the thing is, for each and every of these integers, some of these are white, some of these are black, according to the problem. So we will have to tell the number of black integers to which these elements can reach. Like in this case, among these elements, this one is black and this one is black. So all four of these can reach to two black integers. And this guy can reach here, this guy can reach here. One of these is black, so both of these can reach to one black person, one black integer. So what we have to do is we have to print this. The number of black integers an integer can reach, and print this for each and every of these. I hope the problem is clear. Yeah, Tushar, exactly.
Yes,
Okay.
so
Okay, I hope the problem is clear. Now the thing is, let's simplify the problem and just assume that 3, 5, 6, 1, 2, 4. So let's assume that you had to find out the answer for only one of the elements and not for all of them. So how would we do it? We can just simply say that, bro, start from this index, go wherever you can, from there, go wherever you can, from there, go wherever you can, and do this as long as you are going somewhere else until you reach to a place where you have already reached. Now, in case if this array was not a permutation and if this was just a normal array where you could have duplicates, then there was a possibility like you might have maybe a 6 here and you reach to this place again, thus forming this as a cycle. But in the current case, if you're having a permutation, then my claim is at some point of time, from wherever you start the uh, this cycling process, basically the process of going at some other place or whatever you say, this tour you had, you would at someday reach to the same node once again, same index. The reason being that it's like for each and every one of the indices, they have exactly one place where they can point to, and there would be exactly one place which will point to the current uh, index, because you're having a permutation of elements. So uh, there will be exactly 1, 3 in the array. So you can just assume it in a way like we look at graphs. If you know about graphs, then assume it in a way like graphs. Otherwise, try and this at the normal array. Like you're having an index, maybe like 6. It will definitely point somewhere. You reach to 4. Now this 4 must also point to some place. Let's say it is pointing to 1. Now this 1 should also point to some place. Let's say it is pointing to 3. Now this 3 should also point to some place. Maybe let's say, not considering this, maybe let's say it was pointing to 8 or something. You know one thing, this 8 or whatever other elements you had can never point to, or this can never point to something which is being pointed by someone else. Like the reason being that all the elements should be unique. All of these elements should be unique. So uh, you had a 6 somewhere, right? You already had a 6 somewhere, or you already had a 4 somewhere. So you will not have any other, you will not have a 4 at any other index, or you will not have a 6 at any other index. So this possibility won't be there. Like this is the main thing which you had to notice. Something like this will never happen, which makes sense that at some place, like they say it might point to something else, but at some point there should be some index where we reach, which will point back to the current index. Guys, are you able to visualize this? I know it's not going to be clear by just listening. You will have to try to visualize it in your own mind and try to think about a counter test case. That's the best thing for understanding. And yeah, you surely need to do this uh, for practicing so that you would be able to think about these things on your own during contests. So shall we move on? Like, did you guys get the idea that at some point of time, you will reach back the current index and you would not reach to any one of the other index, uh, like this, it's a sort of a cycle. If you see, a cycle is being formed. So the cycle won't be created by going something like this instead of this. It won't happen. You would definitely reach to the current node only, current index, whatever. So
Because
the
the
idea
elements
is,
are unique, sir.
yeah, because the elements here are unique. This is a
Yes.
permutation. Like
Yes.
not just the unique part, but the part that all these elements uh, are
Are occurring only one
forming a
time.
permutation.
Yeah.
Yeah, they are coming exactly once.
Yes.
Okay, tell me one thing. Can I say that from any of these nodes, I can reach to any of these nodes?
Yes, sir.
I can say this. So whatever number of black nodes, whatever number of black integers this guy can reach, this guy will say that, hey, I can reach the exact same number of black integers, right?
Yes,
This
sir.
guy will, this guy will also say the same. So the answers for all of these would be the same. Should I calculate them differently, or can I just say that whatever answer I got for this one, I will say that this is the same for all of these. I won't count it again. I won't go to the tour again. I can say this, right? And what I can do is for each and every element, I can just say that, hey, wherever you can go, just go on. I know that at some point you will reach back to the current place. Once you reach back, now you know all the people you had gone through. You know the number of black integers you came across, you encountered. So you will have a count of black. Just go through all of them once again and mark, like tell them about this count once. Maybe let's have a vector of integers answer and just go through all the nodes and all the integers and give this value to them. Right.
So, or we can use stack as well. So
Yeah.
that we can push the nodes or the values.
Yeah, it doesn't matter whether you use a stack or a queue or a vector or a set or whatever.
Yeah.
All you want to do is just go through all of them once again. Yeah, if you want, you can even go through them by the same way as we had done earlier. That thing will also work. Okay, so coming to the point, you can assign these values easily. Now let's say, uh, like you have got the value for one, then you did the exact same thing for two. You had a cycle for two, and you were able to find out the number of black integers two can go through, two can reach. Now you want to find out the answer for three. Will you really do this thing once again? Obviously, no. You will just say that, hey, I already know about the answer, so I will do nothing and I will just get the answer. Similarly for four, four was here. So again, for four as well, I won't really do the thing again. I will just ask answer because in the answer I would have filled the answers for all of these and so on. So if my cycle is going through 10 nodes, yeah, for finding out the answer for node 1, it took me 10 iterations. But for the other 9 nodes, I won't really go to all those iterations again. So I can say that for n nodes, I'm having only big O of n iterations. Does it make sense? That the time complexity is not so bad. It's actually cheap. And yeah, that's it. So guys, is this problem clear? Great. Let's look at the code. The code is also simple. I'm first of all taking the inputs and then going to each and every node. Then for each and every node, I have been checking if I've already visited this node or not. Otherwise, I will go through the complete path, count the number of black integers I get, and keep track of all the integers I've gone through. Then at the end, mark the answer for all of those. And I have been visiting them whenever I'm going through the tour so that I won't go through them once again. And then at the end, I'm just printing the answer. Pretty simple, right? At least for being the D problem, I think it's pretty simple. Earlier, I think D problem used to be a bit more implement heavy. Whatever. Let's look at the E problem now. Okay, so for E problem and F problem, I think F is simpler, but let's do the problems in order for now so that the ones watching on YouTube don't complain. How many of you actually attempted this problem? Can you guys tell me in chat? Okay, Ritesh solved. Nice. What about others? Oh, missed by 1 minute in debugging. That's bad. Like that's unfortunate. Bad.
Those were very heavy on prefix suffix side.
Yeah. Like not very heavy, but if you miss out at some place like I did, then it can be heavy to debug.
Yeah, that's all what
Yeah.
happened. Debugging the entire array, seeing which point.
Yeah. Secondly, the time limit is 2 seconds. And yeah, I think we should not discuss anything else. Earlier, I was thinking about discussing something else, but I think we can skip. Like the earlier approach which I had in mind looked like it will take around 1E8 operations, but it got TLE. And even for Dominator, his approach took 1700 ms, so he might also get uh, what do we say, FST, or at least it would be really really close to 2 seconds. So the problem says that Sakur Rako really loves altering strings and okay. So there is a person Sakuraku who is really obsessed with strings, at least from the start of the contest. And he says that if you are having a string like a b a b a b a b, it is gonna be considered as altering substring. The conditions here are for all the elements which are coming on the odd indices, they should be equal to each other, and all the ones which are coming on even indices should also be equal to each other. Now there is no constraint on these two. Like even if you have a string like a, this is also gonna be considered as altering because these people are equal and these people are equal. I think it's simple to understand. Secondly, the length of the substring should be even. Sorry, length of the string should be even. Um, this is something strange because even if we have a string like ABA, we do consider it as altering substring, altering string. But the problem setter decided that the string should be even in length, and we have been given a string. Like we have a string, uh, we would be given as an input, and there are two type of operations which we can apply on it. The first type is to just choose an integer, sorry, choose an index I and delete it from the string. Bye bye. Second thing is choose an index I and replace it with any other letter. So if you have something like A, B, A, B, A, B, A, A, B, A, B, A, B, then in that case, deleting this letter will make the string A, B, A, B, A, B, and then A, B, A, B. Basically, the string will become uh, alternating. And if you had something like A, B, A, B, A, B, in that case, replacing the character by B could have made it good in one move. This was my initial thought that where would be deleting process good and where would the replacing operation be good. I had just forgot about this condition that we can not apply operation more than once, uh, and wasted a lot of time in the contest. Later on, I realized that hey, we can't apply the operation more than once.
Say example, if that condition wasn't there,
Yeah.
like then it would have been purely greedy. What was your thought process?
In that case, my thought process was that whatever string I have at the end of the day, I know that the elements at the odd indices should be the same. So I have only 26 possibilities for what character there can be. Similarly, for the even in positions, there are only 26 possibilities. So I am having 676 possibilities on what the uh, altering substrings can be. Like not really 676 possibilities because the length can also vary for the strings because we can delete characters. But you have only these 676 possibilities of which you have to consider. Then
Multiplied the size is also possibility, right? Because
uh, no. The thing is, if I want to form a string like this one, let's say I want to form a string which is similar to this pattern. Like then whatever string I have, I would just like to have
Two
like I would
characters
just
to be chosen.
yeah, I would just like to make sure that for all the odd integers, I make them equal to A, and for all the even positions, I would like to make them equal to B. And I don't really care about the length. I might have a string only
that
this big or
minimize
this big. Huh?
how will that minimize the operation? Because
Um,
you are
we can
allowed.
actually apply DP. We can apply DP on that. And add actually coded up this. And after a lot of struggle, I realized that, okay, we can apply only one operation. So I did some modifications and unfortunately it got TLE because 676 into 2e5 comes up to be around 12, 13, whatever, uh, e7. So it is around 1 to 2 e8, no, between 1 to 2, like 1 e8 to 2 e8. And since we are having DP, we are actually having a lot of constant factor as well. We are allocating a lot of memory and deallocating the memory. So these 1E8 iterations won't be as fast as the 6E8 iterations we were discussing a few problems ago. These
So
would
at
be a
the point, your DPA will be considering two possibilities, right? Like delete this element
either
or
either remove or change.
remove or
So
change.
yeah,
Change is 676.
uh, like for all these 676 cases, I was applying the DP again and again. In the DP, I was having three things. The
Yeah.
first was the number of elements I have considered. The second thing was um, like depending upon whether I have deleted an element or not. Uh, or maybe you can just consider the parity. Yeah,
Okay.
the third field was unnecessary. So you require these two fields. The number of elements you have already considered and the number of elements you have deleted, the parity of the number of elements you have deleted. On the basis of that, you can decide whether I should have for the ith index. Let's say if I say you're at the ith index and the parity is 1, then you know that you have killed one of the elements till now. So like if the parity was 0, then for odd I you might have been willing to it have been equal to 0, but sorry a. But if the parity is 1, you know you have killed one of the people till now. So even if I is odd, you must have a b at the ith position.
This is considering you are killing only one time, right?
uh, I'm killing, like I might have killed any number of people, I don't really care. The parity should be 1. Like if the parity is 1, in that case,
Okay,
if
okay.
the, yeah, because it does not matter whether I have deleted 3 people or 5 people.
Mm-hmm. Can
Okay.
you paste your solution? I won't like block others in the
uh,
chat.
yeah, we can discuss about this after the session.
Yeah, yeah, sure.
Actually, since we could delete only one, this approach was incorrect, so I never got to submit it. It failed on the sample test cases, and then I had to change the approach.
Oh,
So I can't share the code. Later on, but I had noticed this part, so I had made some changes that instead of having it as the parity, this would be a hard limit. And there was one more thing. If let's say, yeah, by the way, one more thing. As soon as I had seen this thing, this condition that we cannot apply more than once, uh, I had one observation which I believe you guys should also have, that if you're having odd length of the original string, then you must apply the type 1 operation at least once, exactly once. And if the length is even, then you should not apply. Yeah, exactly. As Ritesh is also mentioned, that if the length is odd, then you must apply it exactly once. And if the length is even, then you cannot apply the type 1 operation, because you can apply it only once. And after applying it once, the length will become odd and you won't be able to apply it anymore. So at the end of the day, we know that if the length is even, the case is simpler, because we know that we can apply only type 2 operations. So let's think about the even case size, even size case. If the string length is even, then whatever string you have, let's say you are having the string Raghav on maybe uh, code or whatever. So you know that you want to make RGVOE, RGAOE. Let's say that there is a variable like whatever AAA. This is also the part of the string. So you would like to have all of these characters being made equal. And this is pretty obvious that you would like to make all of them equal to A, because these are available in majority. You will have to make changes to less number of people, right? So the case is pretty obvious. If the string is of even length, you can just look at all the people with which are present on the odd positions, and then find out the frequency of each and every character. Uh, like you found the frequency of A, B, C till Z, and then let's say C is coming up 10 number of times, which is the maximum. Then whatever was the total length of string, it was n, then your answer would be n by 2 minus 10. Right? Like this would be the number of operations required to make all of these equal. Similarly, you would do the same for these. Guys, does it make sense? This is the easier case to deal with. Yes, no, something?
Yes, sir.
Okay. What about others? Okay, great. They are also there. This one's again. Yeah, there are 7 people in meet, including me. So 6 are there. And only 2 of you are replying. 3 of you. Okay, let's come back to the case where we are having n being odd. Like if n is even, then the problem is really simple to do. But what if n is odd? In that case, there is again one thing which should ring in your head, that you have to apply the operation exactly once. And since you have to apply it exactly once, how many choices do you have? You have only n choices where you can apply the type 1 operation, right? So for all of these cases, like let's say if I apply the operation on this place, I delete the first element, then I will have, like I would be left up with an even length string on which I cannot apply the type 1 operation. And we already know how to deal with it, right? So can I say that for all these n cases, you're having n possibilities where you can apply the type 1 operation, deal with them. One way to deal with them is just iterate over the complete string, find out the frequencies of all the odd positions and for the even positions, and then count the answer. The other thing is, like the problem here is you can't really iterate over the com complete string again and again. It is gonna be very costly. So you would like to do some pre-computation, maybe something like prefix sum arrays and suffix sum arrays, so that you can find out the frequencies of all the elements on odd positions or even positions very efficiently. So you would like to do some pre-computation, and prefix sum array comes up at the top inner hit, prefix and suffix arrays. To make it something like big of one, basically constant time. So the idea is, let's say if this was the string and I deleted this guy, then all the people who were on odd positions earlier on the left will still remain on the odd positions. But all the people who were on the even positions, and or maybe let's consider the ones who were on the odd positions on the right, will now come up on the even positions. And the ones which were on the even positions earlier will now come to the odd positions, right? So what you want is, once you delete this guy, you want to know about the total frequency of A on odd positions on left and on even positions on right. Similarly, for B, the frequency of B on odd positions on left and even positions on right, because the ones which are on even position right now will come on the odd positions after deletion, right? And similarly, you would like to know about the frequencies of elements on even on left and odd on right. Does it make sense?
Yes, sir.
Okay, great. Now we have applied the logical part. It is just the implementation part left now. That how would you use a prefix sum array or suffix sum array or any other data structure of your choice or any other algorithm for keeping track of how many A's you are having on odd positions on left or even positions on right till this index, right? Like if you're deleting this guy, then you want till this place. And on the right, you want to start from here. So for this, what I did is I created a 2D prefix sum array, like prefix array. which was like prefix of n26. So if I say prefix of 10 comma like 10 and in the next bracket it is, let's say, 7, then it will tell me about the number of times h. H is the 8th character which is coming up on index 7. Like if you are writing 0 1 2 3 for ABCD, then 7 is representing h. This prefix of 10 comma h in my case was representing the number of times h has come on the indices 0, 2, 4, 6, 8 till 10. So I'm already having only the even indices. And similarly, prefix of 11 comma maybe let's say 2 will tell me about the number of times C is coming on one of the indices 1, like on the indices 1, 3, 5, 7, 9, 11. So this is something uh, in which, like, this is a way in which I did. Now, how did I think
Raghav,
about?
like how many arrays you used? I used four, like prefix even, prefix odd, suffix even, suffix odd. So how many did you use?
In my case, I did use two. One for prefix, like this, I only created one array in which I am storing for both even and odd. And similarly, I did create one array for suffix arrays. Sorry, yeah, the suffix array, which was also containing both for even and odd positions inside itself.
Okay, so like you had to, post deleting, you had to iterate over prefix I minus one and suffix I plus one and
I think
check
it would
the
be great if I
yeah,
first
yeah,
cover
yeah.
this up.
Sure.
Okay, so I was just telling about the way in which I implemented it. Since this is the E problem, I think the people coming up here can try out their creative ways for implementation. This is just one way. Some people might consider having something like uh, a prefix odd array. Let's say you name it something like prefix odd of length n and 26,
Then
where
it should be of length n by 2, na?
it's up to you. Like you can create for n by 2, you can create for n. Um, like it depends upon the way you like to implement. It won't really
Yes,
affect
sir.
much on the time
Yes, sir. Yes.
complexity,
Yes.
right? If you're thinking about creating for n by 2 size, then I think my way is a lot better because
Yes, sir.
you will have less number of variables. Sorry,
Yes, sir. A less
yeah,
number of arrays.
yeah, less
Yes.
arrays. Code will be less cluttered.
Yes, sir.
Okay, so some people might even consider not creating a suffixum array. Like you don't really need to
Yes,
create a
sir.
suffixum array. You can just create a prefixum array and use this for calculating the number of uh, A's you have on the odd positions or even positions. You can very well do it with just the prefix summary. You don't need the suffix summary. In
But
my code, you will see I used it just for simplicity.
yes, but it will involve some amount of math.
No, actually, it was making things simple. If you're using a prefix summary and you want
Yeah.
to find out the sum from here to here, then you will have to think uh, whether this guy exists or not. If this exists, then I will do this minus this and think about this much. In case of
Yeah,
suffix summaries, I could just straight away say that, hey, start from here, go to right.
yeah, that was I am also saying that if we only use prefix 2D array, then it will involve some
Hmm.
amount of mathematics as well.
Yeah. Yeah. Basically, it will introduce more chances of making mistakes.
Yes.
Yeah. So the part of implementation is something you will, like, I'm saying this for everyone, that the part of implementation is something people get better by practicing on their own. So I don't think we need to discuss much about this. And uh, there is one more thing, like the way in which I like to code might not look very good to a lot of people. they might have other preferences. So I think it is doable now, and you guys can try it out on your own. And there is one recommendation from my end. Once you try to implement it on your own, like the very first step should be to try out on your own. After that, look at the grandmasters or legendary grandmasters sports, because those people who are having a lot of experience generally write very, very clean code. In my case, my code is very bad. During the contest, I had made some mistake, like typing error, and for finding it out, I had written a lot of extra redundant code. So I think it would be better to look at the legendary grandmaster's codes instead of looking at my code, at least for this problem. And if there is something related to logic, if there is any doubt related to logic, then please ask. But I think we can skip the part of looking at code.
Sir, how
Yes.
you came up to the thing that we can use prefix array here or suffix array here? Uh,
Yeah, I can explain.
is there
So,
any intuition for that?
yeah,
I
let me
got
explain.
understand that n into n is getting into O of n square.
Hmm.
So for reducing the other n, the
Hmm.
portion that we are deleting one element at a time,
Yeah.
how do you think that we can use prefix array or something like that?
Yeah, the idea was for each and every index, like I will consider each and every index that I can delete this one, I can delete this one, I can delete this one. What I wanted was each and every time the goal was to just find out how many A's are there on the odd indices or how many B's are there on the even indices or whatever.
Yes.
So for this task, prefix sum array is something which should directly come in your mind. At least in my case, it directly came in my mind that since I'm not changing the values of the elements and I want to find out the uh, count
Yes.
of elements, even if I want to find out the frequency for alternating elements, it is still possible with prefix
Yes.
summaries. Uh, this is something which improves with experience. Uh, I think everybody do notice that when you compare yourself from last month, you notice that now I'm getting better ideas, uh,
Yes.
getting intuitions more easily related to implementation. Okay, so anybody having any doubt related to logic? Uh, I will surely show my code, but I don't think it's something you should look at. It's horrible. Okay, so if there is no doubt, let's go to the code. So yeah, here is just an idea that the code is super long and it's having a lot of redundant things like this. Yeah, by the way, wherever you see the DBG thing, just ignore it. It is used for uh, printing out the vectors very easily. Like just writing this single line will print both of these vectors completely. So the main logic here is, first of all, I'm taking inputs, then I've been creating a prefix sum and suffix sum array, like not the sum, but prefix and suffix arrays. And in case if the length is odd, sorry, length is even for the array, sorry, string, in that case, I'm straight away, uh, basically I've created a function with name get answer, and I'm using that to get my answer. And if the length is okay, so the function which I've created with name get answer, inside this, I will pass on an index which I want to delete. So when I'm having the length already even, I don't want to delete anything. That's why I have been passing n here, uh, which does not exist inside the string. We are having only indices from 0 to n minus 1. And in case if n is odd, then you are like I am checking if I delete this I. And if I would delete the element on the ith index, I would be using one operation. So I'm having a plus one here. And now coming up to the part of how am I checking if like what will be the cost if I delete this guy. Then for that, with the help of the pre-computation I had done, I am able to get the uh, frequency of all the characters on on even positions and the odd positions, and I'm storing it inside a vector. Here is the process of how I'm calculating it. Ignore these lines; these were just for the debugging purpose. And yeah, in case if I'm not deleting anything, uh, then I'm not sure if this will do some problems for me or not, if it would be good or not. Uh, just to not take any risk, I uh, yeah, overrode this. This is why I was saying that my implementation is really bad, because if somebody is coming up to read this, he would be confused that what are you doing here and then why are you doing this there. But let's skip it for now. And then at the end, I'm calculating the cost. So the cost would be nothing but maximum minus the sum. Now again, the bad part is I'm calculating the sum in this way, but uh, we know the sum should be n by 2. This is something I should have been checking by an assert statement instead of using this sum here, but okay, at least it is working correctly. And at the end, I'm
For
just returning cost.
finding the frequency, like the can you go over number 3 in your code? Yeah, for finding the max frequency of evens and odds, you basically have to iterate over your prefix array and check where each character is lying, right? If it's lying on one
Uh,
position, then you consider it odd. Right? For
Actually, I
example.
think it is better not to discuss this part, like which is related to implementation, because the way in which I have implemented this is not good.
Oh,
Yeah, this is neither clean, and I don't encourage anyone to um, like try to implement in this way. Instead, it would be better to just go to the leaderboard and look at the
yeah.
grandmasters codes. Yeah, the main thing was logic, and for the part of implementation, everyone else, like everybody has their own preferences, so they should try to code it on your own and look at the grandmasters for improvements. Okay, I think it's good enough. Like the explanation for this problem should be good enough, and it should be doable now. So let's move on to the next problem. Shall we move on, or anybody having any doubt? Okay, so let's move on. This is sorry, yeah, this is F and the final problem which we are discussing today. Um, I'm not sure if the next problem was doable or not. Like I could not try it much before the PCT. So we will discuss on little the problem. And this is far simpler than the previous one. F problem is actually sort of conceptual. Let me explain the problem. It says Sakurako has a box of n balls. Each ball has its value. She wants to bet with her friend that if the friend randomly picks up two balls from the box, um, the product of those two balls, the values on those two balls, will be the same as the number that Sakurako guessed. Now they have just clarified that um, it just has to be two different balls which her friend is picking up. Um, the two balls can have the same value, it won't be a problem. So they are saying that Sakuraka knows that the best number to pick up is the expected value, but she forgot how to calculate it, and we have to help Sakurako and find the expected value of the product of two elements from the array. So the problem is nothing but you have been given an array. There will be some elements in the array. And you know that somebody is gonna come up and pick up any two random integers from the array and do their product. You want to find out the expected product of these two elements. So we know that expected value is nothing but a weighted average of the values multiplied with the probability of getting those values, right? So this is nothing but the expected value, or the way we calculate expected values. So here they have not explicitly mentioned, at least I think they have not explicitly mentioned that the probabilities of each and every pair or for each and every ball is the exact same. But since they have not mentioned any bias, I did assume that the probability of him picking up ball 1 and ball 2 would be the same as the probability of him picking up ball 2 and ball 4. So basically, the probabilities should be the same for each and every pair. So expected value would be nothing but, like in this case, the expected value would be the sum of AIAJ divided by here I is going from 1 till n and j is going until I plus 1 till n divided by nc2. This is the number of pairs and this is the sum of products of all the pairs we can have. So we just have to calculate this thing. Now the number might be very huge. So we have to print, yeah, at the end of the day, the answer might be coming up like P by Q, where uh, P is very huge, Q might also be very huge. So we have to print P into multiplicative modular inverse of Q. So they are representing it as P and Q inverse. And we have to do it with mod 10 raised to the power 9 plus 7. Now, if you are looking up at an expression like this for the very first time, congratulations. You are going up to a next level or whatever. What can I say? At least when I did look at something like this for the very first time, it looked confusing to me. At that time, I had no idea of what we are doing and how we are doing. So I do suggest a video by Utkarsh Gupta. Like Utkarsh Gupta has created a video on YouTube with a name like Maths for CP, Maths for Competitive Programming. I think something like this. Maths for Competitive Programming. So I do highly recommend you guys to go to that video first. He has covered up some very standard things for mathematics and competitive programming, or like I don't know if we should call it standard or not, but very useful things. If you watch that video and understand it, then this thing wouldn't look confusing and you would actually know of what we have to do. So uh, after this, there is one more thing you can look up for, that is search for modular and struct. Maybe search something like this on Chrome and you will come up against a struct which has named something like ment. Some people name it as ment, some people name it as mint, some people name it as mi. Jiangli names it as z. Basically the name is mint or something, but he typecast type definition it to it, like type def it to z or whatever. So look out for these things. It can make your work a lot simpler. So I think just doing these two
What
tasks
is
would,
this mint?
uh, I think it would be something you can study on your own once you know about, once you have watched this video. Uh,
Yeah,
Baki, I will
this was
show this
Q
in my code.
inverse was the Fermat's theorem, right? Simply.
No, no, no. I think, like, I don't remember the names of these theorems and all. But I think Fermat is something else. Like, I'm not sure about the names. Uh, for this, it is like, uh, I don't even remember the correct names to define it. I think it is known as multiplicative modular inverse or modular multiplicative inverse. It is there in the video. Like Utkarsh Gupta has explained it very well. I can never explain that well, so it would be better if you just watch that video. It will give a lot better clarity of the reason why we use multiplicative modular inverse or modular multiplicative inverse, whatever it is. Was this covered in yesterday class in level 3? Oh, nice. Okay, so level 3 people learned about something yesterday and they got it and used it today.
Yes.
Nice. Nice, nice. Okay, anyways. Uh, you just have to do some simple uh, modifications in it. Just use the idea like if you're having something like a0 a1 plus a1 a2 plus a0 a2 or yeah, something like this by 3, and the product of these two, like the product of a0 and a1 is going above mod, where mod is equal to 10 raised to the power 9 plus 7. Then at the end of the day, let's ignore this by 3 for now. Let's just consider this part. If you're having something like the sum of these three elements and the product of these two is already greater than mod, then at the end of the day, after adding up all of these, when you do mod, something would already go down now. Like you just have to realize that there will be a lot of places where you can take the mod in just instantly, like multiply a0 and a1 and then take the mod. The reason is something like, let's say if mod was equal to 5 and um, a0 was, let's say, 4 and a1 was equal to 6, then 4 into 6 plus, let's say the product of these two came out to be 0 and the product of these two came out to be 0, or maybe let's say that it came out to be 10 10, and you had to take the mod 5 at the end. This is 24 plus 10 plus 10. So basically, just for those who didn't understand, what I've done is, instead of a0 and a1, I have just said that let's say it is coming up to be 24, and for the other two, this is coming up to be 10 and 10. Ideally, we would have been doing mod 5 at the end, but if I just like at the end of the day, it will get broken down into 25 mod 5 plus 10 mod 5 plus 10 mod 5 mod 5. We can write it like this as well. It's up to you if you call it as a formula or if you try to just visualize it, because visualize it in a way that from this 24, removing 20 will not change anything because the remainder will still remain the same. Like whether you had a 4 here or you had a 24 here, at the end of the day, when you do the mod 5, the progress would be lost. Like this gaps of 5s would be lost. Um, I'm not exactly sure of how well am I able to explain at this place. Uh, Guys, did you get the idea which I wanted to tell? And actually, this is also something you will get to learn from this video. To be honest, I was a complete noob when I had watched this video. And it was like I was maybe a newbie when I had watched this video, or a pupil, whatever. And until I reached CM, I had sort of watched, like, learned nothing other than this. The content which he discussed, I had learned nothing other than this until my journey till CM or maybe high expert, whatever. Of the I don't remember, and it doesn't matter. No, no, no. I'm talking about content for mathematics. DP and all is unrelated to this, or something you will still have to do. I was talking about the content related to mathematics. You won't really have to go through all the other algorithms which he has not discussed. Just going through all the things which he has discussed is good enough, at least till CM. Okay, so um, I think I did a lot of irrelevant explanation here. Okay, let's come back to the problem. Overall idea is we just want to find out uh, this expression by NC2. We want to find out this expression. Now we can't really run it in big O of n square, but what we can do is, you know, like mathematically manipulate it a bit to make it more optimal. You might come across this kind of thing even more than once, even in some other simple problems. So the idea is AI would have to be multiplied with A0 as well. It would have to be multiplied with, or maybe let's take A10. The index 10 would have to be multiplied with A0 as well. It should be multiplied with A1 as well. It should be multiplied with A2 as well. Or maybe let's make it even simple. For the first case where we are talking about A1, let's talk about one-based indexing. It should be multiplied with A2. It should be multiplied with A3. It should be multiplied with A4, A5, A6 until AN. And we want to take the summations. So can I say that it is nothing but A1 into A2 till AN? Similarly for A2, we want to find out its product with everyone, obviously other than A2. But you have already calculated A1 into A2 at this place. So for A2, you want to find out A2 into the sum of all elements from A3 till AN. Then for A3, you want to find the product of all, like, sorry, A3 into summation of A4 till AN. Then for A4, you want to contribute this and just take the summations of all of these. Is it making sense? Is it making sense? These two things are okay. Whatever we have done here can actually be manipulated from this very easily. It is nothing but okay, just 1 second. Maybe we should turn it off. Sorry for the inconvenience. Okay, so yeah, this AI is independent of this for loop, so we can bring it out. We can write it as I from 1 till n AI multiplied with j from 1 till n aj. And finding out this part won't be difficult. We can either do some pre-computation like creating a prefix sum array or something, or we can just use a simple single variable as well. Like we people are smart enough to at least optimize this part. And at the end of the day, we will have to divide it with NC2. So you will have, like, you can just consider it as multiplying it with inverse of or inverse of NC2. And when I say inverse, I'm talking about modular multiplicative inverse. So this is our expression at the end of the day. We have to find out I equal to 1 till n ai multiplied with n j plus 1 aj, and this whole expression being multiplied with inverse of nc2, and we have to find out the mod of all of this. So you can just use up your idea that uh, at what places you should do the mod part. If you are looking up at this kind of a problem for the very first time, then it might look confusing, but eventually it will look easy. Like you don't really need to find out the complete sum of all of these elements before taking the mod. While just adding the elements, you can take the mods, and as soon as you multiply two elements, you can again take their mods before adding. And once you add these elements, you can again take the mods. Then after multiplying, you can again take the mod. So uh, I think this is something doable, and it would be better if you try it out on your own. Um, it's not worth explaining or not good to explain. Okay, so anybody having any doubt related to the approach? Like we have left some task for you on uh, applying mod part everywhere. I will show it in my code though. Like if you are doing something like this for the very first time, then I do recommend you guys to use the mod again and again by your own everywhere. But if you're already habitual to it, there is something like mint which you guys can use. I will show this. I will show you what it is. In that case, you never have to worry about mod. Just never worry about it. So here is my code. There is a code snippet like this one, which I have copy pasted from my GitHub. You can uh, also copy and paste it from your snippets or somewhere else snippets, or if you want, you can use my snippets as well. And then there is another snippet which is not being used, so you can ignore it. Here is the code. First of all, I'm taking the inputs. After that, I'm calculating the sum of all the elements so that I would be able to achieve this part. And I've been doing this here in the for loop by just removing AI every time from the sum, and then adding the sum into the current element into the total sum. Um, and then at the end of the day, I'm dividing it with this NC2. So yeah, you don't even need to worry this much. You can just write it as simple as this NC2 in the uh, denominator and just print it. Yeah, somebody is even saying it in the chat that my code is looking clean, whereas he had used a lot of mods in his code. And that is what used to happen with me as well until I got to know about this thing. It is really cool. It makes things very simple because You are like, you see, we just wrote something mathematically, and now we are writing it exactly the same way in the code. We don't have to worry about all the mods. Uh, and when you write mod everywhere again and again, like at the time of adding here, you would have to write the mods, and even at this place, even at this place, even at this place, and so on. So you are
So
having more
you
chances
have
of making mistakes.
like done operator overloading in your stuff?
Yeah, there are a lot of operators being overloaded.
Okay, 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 okay. And in case of division, it is B inverse. Okay.
It is using the inverse. Okay, so I don't think I have much to explain in this problem either. This is something uh, you will learn mostly from the video I uh, told about. This video. Oh yeah, there is one more thing. You can watch Love's playlist also. You can maybe just search Love Sleepy playlist and look out there. He has also covered the concepts related to mathematics. He has covered more concepts than Utkarsh, and I think most of them would be like sorry, not most of them, but the concepts which he has discussed and Utkarsh did not discuss are not used that much. You can skip that part. Uh, but for the concepts which Utkarsh has discussed, you can watch them from Love's playlist as well. Love has dedicated a lot more time in explaining and has uh, uh, like provided some sample problems as well. So I think these two would be enough. And for the part of Mint and all, you can look at my code snippet. You will find out the solutions in the description. Like, I will share my code submissions in description. Uh, this one, let me check. I hope you have not shared a bad link. Yeah, this playlist is really good. Loves playlist. You can see that I have watched so many videos and almost all of them. Yeah, I have watched almost all of these videos relate which looked relevant to me. I have skipped some from the beginning because I had already known about those, but watched all the videos after that. Okay, so I think we can end the session now.
Uh, Raghav, can you like discuss a little about G as well? Just above kind of like
Which thing?
higher G problem.
G problem. Actually, I have not tried this problem. I
Okay.
yeah, I did only till if, and then I knew that I wouldn't be able to solve it and prepare for covering in the PCD, so I left it for tomorrow.
Okay, got it. Thanks.
Yeah. So good night.